Hello, Trig class. This is the last section before I come back. This is 7.7, graphs of tangent, cotangent, cosecant, and secant. So the first part, we're going to look at the graphs of the function of the form y equals a tangent omega x plus b, and y equals a cotangent omega x plus b. A is the amplitude. It's not going to behave like it did with sine and cosine, and also omega is going to be your stretch. So it's either going to make the graph skinnier or it's going to push it out. So it's going to be compressed or stretched. All right, so the plus b, while I'm at it, either moves the entire graph either up or down. So let's go ahead and remember that tangent from last section, tangent period is pi. It is not 2 pi like sine and cosine. So what does that mean? That means that we'll see the same graph over and over again every pi units. Okay, we have to watch out for all of these functions, tangent, cotangent, cosecant, and secant, because there are places where they are undefined. Places like 0, because we have 0 over 1, that's okay. The vertical asymptotes are going to be at pi over 2, and then 3 pi over 2, and if you remember that we said they were odd multiples of pi over 2. So that is why when we graph this, we're actually going to graph from the first asymptote to the second asymptote around the 0 mark. All right, so that's why we're graphing it like that. The reason why is we want to see a continuous function. So in order for it to be continuous, we have to do it from negative pi over 2 to pi over 2. All right, so we know that at negative pi over 2, tangent is not defined. And at pi over 2, tangent is not defined. So the first value we're going to actually look at is actually in quadrant 4, because we're doing negative values. We're looking at tangent at negative pi over 3. Okay, so remember pi over 3 is 60 degrees. Tangent at 60 degrees is the square root of 3. So I want to make a note over here that the square root of 3 is equal to 1.73. So this point is negative pi over 3, comma, negative 1.73. Okay, moving on. Tangent at pi over 4, it's negative. Tangent at negative pi over 4 is going to give me a negative 1. So this is negative pi over 4, comma, negative 1. Tangent at negative pi over 6. Now remember, a tangent at pi over 6, or 30 degrees, is going to be radical 3 over 3. And radical 3 over 3 is equivalent to 0.577. Okay, so this becomes negative pi over 6, negative pi over 6, comma, negative 0.577. Okay, and I'm sorry, these boxes are small. Make those bigger next time. Tangent at 0, we're finally at the origin. So tangent at 0 is actually 0. So this becomes pi comma 0. Tangent at positive pi over 6. Tangent at pi over 6 is going to give me the value of square root of 3, which is 1.73. So we get pi over 6 comma 1.73. Pi over 4, tangent at pi over 4 is 1. So we get pi over 4, comma 1. And finally, tangent at pi over 3. This is our 60-degree angles. This is going to be pi over 3, comma, radical 3, which is 1.73. Okay, so now I have my coordinate points. I'm ready to graph out what tangent looks like. So the graph. You're going to have to refer back to that chart or draw it on the same page. So first things first, I got to put my values in. The x-axis is once again my angles. The y-axis is going to be the value at those angles. So this is negative pi over 2. Remember, that's where the asymptote is, so let's go ahead and place that in there. And then we have negative pi over 3, negative pi over 4, negative pi over 6, and then we have 0. And then we have positive pi over 6, positive pi over 4, and positive pi over 3. And then we're going to take this out to pi over 2, which we know is another asymptote. That's where tangent's undefined. So I'm going to put in those values that we found. So the first value was negative pi over 3. So at negative pi over 3, I got 1.73 that was negative. So I did not put those values in there. Let me do that really quick. Okay, so that's going to be somewhere down in here. And then for pi over 4, I got negative 1. And then for negative pi over 6, I got negative half around in there. Okay, so right now what's happening here is your graph is doing this. I'm just kind of gonna, and it's actually approaching that asymptote, but it's not touching it. Okay, so let's draw the rest of it. At pi over 6, we get a negative half, or a little bit more than that. And then at pi over 4, we get 1. And then pi over 3 is 1.7 something, 1.73. So this graph is going to shoot up like this, and it's going to go upward. Okay, so we have our graph of tangent. So this is y equals tangent x. And that's how you graph. That's what's called the parent function. Okay, so what would happen past pi over 2 is you would have the same type of situation going on. And over here, you would have this. So just to let you know, it would repeat, and then you would have the asymptotes every odd multiples of pi over 2. Okay, so let's move forward. All right, there's a nice picture for you in your notes of what tangent looks like, and it shows the graph repeating itself every pi units. And the domain, let's talk about that. The domain is all real numbers except odd multiples of pi over 2. That's where your asymptotes are at. So right here and here and here. Okay, and here, etc. Okay, so I'm going to erase those. All right, the range. The range is the height of the graph. The range is the output or our values. The range for tangent's kind of cool because it's negative infinity to positive infinity. Tangent is odd. What does that mean? That means it has symmetry with respect to the origin. Tangent is periodic with a period of pi. So once again, if you look at it, every pi units, the graph repeats itself. The x-intercepts, the points where it crosses the x-axis, if you look here on these points, it's every pi unit. So it's pi, 2 pi, 3 pi, 4 pi, etc. So if we make that generic, we can say that they are multiples of pi. The y-intercept occurs at 0, 0. And there are vertical asymptotes, once again, at places where they are undefined, which is odd multiples of pi over 2. Okay, so now tangent's in the bag, and you know what that looks like. All right, so let's move forward. The graph of cotangent. It looks like tangent, however, the initial function will go from 0 to pi. The reason is because there are values that make cotangent undefined, one of which is pi. So we have to be aware of those areas. Knowing how to sketch initial function will allow us to represent the function further out. So let's go ahead and look at this. I already did the chart, or actually the book did the chart for you. So remember that the square root of 3, just as a quick reminder, is equal to 1.73. And square root of 3 over 3 is, I think, 0.57. Hold on a sec. Look at my notes, 577. Okay, so with that being said, we can graph cotangent with these values. So once again, x is my angle, y is my value at that angle. So this time around, what I'm going to do is I'm going to take this from 0 to pi. The reason why is there's an asymptote at 0 where cotangent is undefined. And then the next value is pi over 6, 30 degrees, pi over 4, 45 degrees, pi over 3, 60 degrees, pi over 2, 90 degrees, 2 pi over 3. So you take 90 plus 30, or shoot, is that right? Yeah, that's right, okay. Sorry, 90 plus 30 is correct. All right, 3 pi over 4, 135, and then finally 5 pi over 6, which is going to be 150. Okay, and then the next spot is pi. So once again, we have an asymptote there. So let's go ahead and graph this. I'm going to put the 0 point in first. So at pi over 2, it's 0. And then I'm going to go to the left. So pi over 3, we have negative 3 over 3, which is 0.57. So here's 1, here's 2, here's negative 1, here's negative 2. Okay, so we got point like this. And at pi over 4, it's positive 1. And then at pi over 6, it's radical 3, which is 1.7. So basically what's going on with this is the graph is, it should be smoother. It's just how I drew this, but it looks like that. Okay. All right, so let's see what happens on the other side. 2 pi over 3, we get 0.57 negative. And then negative 1 for 3 pi over 4. 5 pi over 6 is negative 1.7, and once again we have this situation. So it looks very much like tangent, except for it's literally reflected. If you had a y-axis, be reflected across it. So they look alike. So let's go ahead and fill out the rest of this. All right, and there's a nicer picture. The domain is going to be all real numbers except integer multiples of pi, because that's where all the asymptotes are at. The range is negative infinity to positive infinity, so it's just like tangent that way. Cotangent is an odd function, means it has symmetry with respect to the origin. And cotangent is periodic with a period of pi, so it's just like tangent. The x-intercepts. The x-intercepts are at odd multiples of pi over 2. And the y-intercept, there isn't one. So there's none. And the vertical asymptotes occur at multiple integer of pi. Okay. All right, so we got cotangent and tangent done. So when you graph these, and like I said, I wouldn't make you do these by hand because they get a little dicey. My advice to you is to do the same thing we just did, to plug in values and get the result using a calculator, okay? But the amplitude does not affect tangent and cotangent like it does for sine and cosine. It basically gives you vertical stretch. So for instance, if you have, regular tangent, okay, that's a regular function. If I make the amplitude bigger, then I have something that gets skinnier. So that's what it does to it. It kind of shrinks or it makes it larger. The omega still is going to affect the period. So if you have to find the endpoint or where the asymptote is, you're going to use pi over omega. So t equals pi over omega for tangent and cotangent only. Shifting rules still apply as they do for sine and cosine. Okay, so for this one, I want you to use a calculator to graph. What I want you to do is to graph y equals tangent x first. Then I want you to graph y equals 2 tangent x, and I want you to see what happens to the graph. And I want these on the same graph, by the way. So place these on the same graph. Okay. And then on your calculator, I want you to do it again, but this time the first function is going to be y equals 2 tangent x. And then I want you to do y equals 2 tangent x minus 1. You'll see that negative 1 is literally going to drop the whole entire graph down 1 unit, because that's what that means. So it still means shift down when you have a negative 1. If it was a plus 1, you'd shift the whole graph up 1 unit. Okay, so the next ones, these are the ones that are fair game, because to do the graphs of cosecant And secant, you have to know the graphs of sine and cosine, and those will definitely be tested. You're definitely going to get tested on them. So just a reminder, the reciprocal functions. Remember that cosecant theta is 1 over sine theta. And secant theta is 1 over cosine theta. So we should know this by now. To graph these two, you're going to have to graph sine and cosine first. Okay, and then the next thing you're going to do is place in the asymptotes. Once you have that done, then you're going to see what happens. So if you notice, and I'm just going to highlight this quickly, like the first graph here is the graph of sine, okay? Cosecant, what happens is it jets off to infinity when we have these asymptotes. So remember that the range for this is 1 to positive infinity. And down here, here's another asymptote. Let's check out what's going on. We have this shape, so it's going -1 to negative infinity. So they make these kind of, I don't want to call them a parabola because they're not quite a parabola, but they make kind of a parabolic shape at those points. So if you have the asymptotes drawn in and you have cosine taken care of, then all you have to do is place in these values on the peaks or the valleys, right? Okay, so that's what it looks like. I'm going to erase all this so we can actually see the graph because that graph, I made it messy. All right, so the other one is the same deal. The reciprocal of cosine is secant. So secant does the same thing. Place in the asymptotes, right? And then once we have the curve drawn in, there's the curve for cosine, then cosecant has these shapes here. So the graph is actually in blue only, but we need the other pieces to be able to draw it. Okay, I'm going to erase that. We're ready to move forward. Okay. Hopefully you guys are getting this. All right, so here's an example, and I think this may be one of the latter pages of our notes here. The first thing we have to do with this is we have to graph its reciprocal. So the reciprocal of cosecant is sine. Okay, so what am I going to graph? I'm going to graph y equals 2 sine x minus 1. Okay, so the parent function of sine, the 4 key points are pi over 2, pi, 3 pi over 2, and 2 pi. All right, this, by the way, you have to have memorized. Okay, so what does sine look like? It looks like this. Okay, so I have the parent function. I notice that I have the amplitude is 2, so I know that I'm going to have stretch, so all my values are going to get multiplied by 2. And I also know that the whole graph, the entire graph, is going to be shifted down 1 unit. Okay? So what I'm going to do is I'm going to deal with this first, and I might have to erase some stuff, so write this down. I'm going to show you the amplitude of sine with 2, and then I'm going to shift it down on 1 graph. So that's going to be our first graph. So I'm going to go ahead and erase this stuff, and I'm writing it down. So once again, what is the amplitude? 2. Hopefully you said that. So I'm going to draw this graph, y equals 2 sine of x. You guys know the parent function. I just drew it for you. So I'm going to take that parent function and apply the multiple of 2 to it. By the way, I'm going into 3's here because I know I'm going to have to shift my entire graph down 1 unit. So that's why I'm doing that. So pi over 2, pi, 3 pi over 2, and 2 pi. I do not have omega, so those points are going to stay put. Okay, so we saw the parent function. Sine at 0 is 0, so 0 times 2 is still 0. At pi over 2, sine is 1, so 1 times 2 is 2. 2 times 0 at pi sine at 3 pi over 2 is -1. So I multiply that by 2, I get a -2. And I'm finally back up to 0 again. So this graph that I'm showing you right now is y equals 2 sine x. Okay, now I'm going to take all those points and I'm going to drop them down 1 unit. So I'm going to do this in purple. Okay, so 0 becomes -1. 2 becomes 1. So I'm literally taking these points and just dropping them down. At pi, sine is 0, so it becomes -1. At 3 pi over 2, sine was -2, so it becomes -3. And then at 2, it was 0, so it becomes -1. So I have a graph here in purple. That is y equals 2 sine x minus 1. Okay, I want the purple graph. Okay, so the purple graph is going to be what I'm going to use. I'm going to set up the asymptotes next because I've already graphed out sine. The asymptotes. The asymptotes for cosecant occur at values of pi and 2 pi. And at 0 if we're going for that. Okay, so I'm going to use a different color here, red. All right, so what does this look like? Here's 1, here's 2, and here's 3. Okay? All right, so I'm going to recopy this down quickly. I'm going to quickly put in red the sine graph. So we have pi over 2, pi, 3 pi over 2, and then 2 pi. Okay, and once again, the asymptotes, I'm going to place those in there really quickly. All right, and the sine function goes up to 1, it went down to -1, and then it went down to -2, and then it went back up to -1. Okay, so here's -1, here's -2. And by the way, if you're looking for that spot where the graph looks normal, remember it's crossing -1. That would be, it dropped down. The whole graph dropped down. Okay. All right, so I have that in place. Now I'm going to draw in cosecant. So once again, here's a valley, or a peak rather, and it's going to shoot off like this. Okay, down here, I'm running off the paper, but it's going to shoot off down there. Okay, so that's what cosecant looks like. Okay, and you're done. All right, so you're finished. Good job. I'll see you guys on Tuesday. I want you to do a couple things. One, I want you to write out or draw the parent functions of sine and cosine. Two, I want you to be able to fill in the entire unit circle. Okay? Three, I want you to understand transformations. Of a graph. This will be on the test, I promise you. Okay, so really quick, I'm going to draw the parent functions for you, but I want you to have these memorized. So I'm going to do sine first. Whoops. So sine x looks like this. So this is pi over 2, pi, 3 pi over 2, and 2 pi. Okay, and then cosine. So this is pi over 2, pi, 3 pi over 2, 2 pi. Okay, 1 and -1. And by the way, if you're struggling with graph, get some help. You know, if you're trying to do this when I'm not there, go see a tutor. And then when I get back, I can help you. Okay, so those are the two parent functions. Make sure you know how to draw them and understand them. Oh, the other thing I want you to do is be able to use omega to find the 4 key points. So what do I change the parent functions? What do I change the values to? You know, how does that work? So be sure to be able to do that. And that's it. So have a nice day. I hope you guys have a beautiful week, and I'll see you soon.